We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Godspeed, John Glenn.
Roger, 0G, and I feel fine.
Getting my feet out. Okay, I'm out.
How does it feel for the United States to be the new record holder?
At last, huh? When that baby lights, there's no doubt about it.
Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
Houston, Tranquility Base here. The Eagle has landed.
That's one small step for man, one giant leap for mankind.
Hello and welcome. This is Michael Annis, and you're listening to episode 103 of the Space Rocket History Podcast. And now, Saturn development, 1957 through 1960. The Apollo capsule design has now progressed to 1961, and I haven't said much about the Saturn launch vehicle development, so today I want to begin catching up the launch vehicle to the capsule. The United States launched 32 Saturn rockets between 1961 and 1975. The Saturn family of rockets included the Saturn I, which was launched 10 times, the Saturn 1B, which was launched 9 times, the 3-stage Saturn V, which was launched 12 times, and the 2-stage Saturn V, which was launched once. Although some flights experienced significant problems, no Saturn rocket failed catastrophically in flight. Saturn rockets were used in support of the Apollo lunar missions, the launch of Skylab space station, ferrying crews to and from Skylab, and launching the American half of the Apollo-Soyuz test project. But let's start at the beginning. Many historians agree that the U.S. took its first step toward the moon in the spring of 1957, 4 years before President Kennedy declared the lunar expedition a national mission. While still preparing for the launch of the first Jupiter, the Army rocket team at Huntsville, Alabama, began studies of a booster 10 times more powerful than the 150,000-pound thrust Jupiter. The 10-fold increase in thrust could put a weather and communication satellite into orbit around the Earth or propel a space probe out of Earth's orbit. The change of emphasis from intermediate range and intercontinental ballistic missiles such as the Jupiter, Thor, and Atlas to a super rocket capable of space exploration signified a change of attitudes at the Defense Department. The change was also grounded in inter-service rivalries that was covered way back in Episode 7. In November of 1956, Secretary of Defense Charles Wilson had assigned responsibility for all immediate and long-range missiles to the Air Force. If the Army was to stay in the big rocket business, it would have to find new tasks for its Werner von Braun team of rocket experts at the Redstone Arsenal in Huntsville. Major General John B. Medeiros, commander of the Army Ballistic Missile Agency, known as the ABMA, set his sights on the new super rocket, subsequently called Saturn. General Medeiros' effort to gain Defense Department support for the big rocket was bolstered by the Soviet Union's accomplishments in the fall of 1957. The Soviets had launched a 500-kilogram Sputnik 2, while the U.S. was limited to an 8-kilogram Explorer 1. It was obvious the U.S. needed a big rocket. In December of 57, von Braun's group, officially known as the Development Operations Division of the ABMA, set out arguments for the new booster program. The super rocket would develop 1.5 million pounds of thrust and serve as a stepping stone to an even larger rocket capable of manned lunar missions. Its early development and adaptation in a multi-stage vehicle could accomplish a number of space objectives pointing toward a landing on the moon in 1967. Although the ABMA proposal was reinforced by the public's embarrassment over Sputnik, approval for the Huntsville project was delayed for several months. General Medeiros' program faced two obstacles: the Eisenhower administration's fiscal conservatism and the priority given to intercontinental missiles. While General Medeiros pressed his campaign, the von Braun Group was not idle. Between April of 1957 and August of 58, ABMA logged 50,000 man-hours on the Saturn project. In early 1958, the Advanced Research Projects Agency, also known as ARPA, was established to coordinate Defense Department space activities. In July, ARPA announced its intention to develop a super rocket. In August, ARPA formally initiated what was to become the Saturn project. ARPA authorized the ABMA to conduct a research and development program at Redstone Arsenal for a 1.5 million pound thrust vehicle booster. To accomplish this, a number of available rocket engines would be clustered. The liquid oxygen and fuel tanks developed for the Redstone and Jupiter missiles could be modified for use in the proposed booster. An existing engine, the S-3D, which was used both on the Thor and Jupiter missiles, could be modified to produce an increased thrust of 188,000 pounds. Numerous tools and fixtures developed for Redstone and the Jupiter program could also be used with comparatively little modification. Thus, it was possible to begin booster development with hardware of proven reliability. Time for design and development of some important booster components and tooling could be significantly shortened and the cost reduced. In September 1958, General Medeiros and Roy Johnson, who was the director of ARPA, established a flight test schedule of 4 Saturn launches. The first was set for September 1960. The third, 8 months later, would employ an upper stage to place limited payloads in orbit. The written agreement between the two men was still shadowed by the Eisenhower administration's reluctance to spend money on non-military space ventures. Director Johnson promised to provide $72.3 million over a 3-year period. The size of the commitment meant that, at least in the beginning, Saturn would operate on a shoestring budget. In fact, the Saturn I program would eventually cost more than $1 billion. The original Saturn design reflected a concern to save time and money and to employ components that could be moved by air transport. So the booster made extensive use of available Army hardware. A contract was awarded to Rocketdyne Division of North American Aviation to uprate the S-3D engine, and after redesign, simplification, and modification, the engine would become the H-1. The Saturn would use 8 H-1 engines and a cylindrical center tank copied from the Jupiter. For its 8 clustered tanks, the von Braun team went back to their favorite Redstone rocket. The propellants would be RP-1 kerosene and liquid oxygen. Transportation from the factory to the launch site was also a concern for such a large rocket. As a result, early plans included a stipulation that no component could exceed 11,340 kilograms or a cross-sectional dimension of 3 meters, which was the maximum limits of aircraft transportation at the time. To meet these limitations, the booster was initially designed with the center and 8 outer tanks separate from the frame and the engine assembly. This meant that the fuel tanks had to be mated with the frame on the launch pad. but this idea was discarded in early 1959 for two reasons. Huntsville engineers agreed that flying out a disassembled thrust unit and rebuilding it on the pad would reduce reliability, and transportation studies indicated that air freight to move the booster would require 11 C-124s. It would be cheaper to build a barge and float the Saturn down the Tennessee River to the launch site. In October of '58, ARPA expanded the program objectives. The new plan was to construct a multi-stage carrier rocket capable of performing advanced space missions. ARPA requested Redstone personnel to study a complete vehicle system so that the upper stage selection and development could begin. ARPA also initiated a study of the Atlantic Missile Range launch facilities to determine if they could accommodate the rocket. But there was widespread disagreement over the location of a launch site. Many wanted to choose an equatorial launch site to take maximum value from the Earth's rotation. However, the Atlantic Missile Range was the clear choice for the developmental launchings. At the range's launch site, Cape Canaveral, the Air Force Missile Test Center provided administrative and logistical support. The range's 10 tracking stations, stretching into the South Atlantic, gave good coverage of test flights. Moreover, ABMA's launch team, the Missile Firing Laboratory, had launched missiles from Cape Canaveral since 1953. Cost and time considerations agreed, as well as the launch site study, which said the Atlantic Missile Range met the established launch criteria in the most efficient and timely manner at a minimum cost. In December of 1958, ARPA authorized the Army Ordnance Missile Command to begin design, modification, and construction of a captive static test tower and facilities for use in the booster development program, and also to determine the design requirements for necessary launch facilities. The Missile Firing Laboratory's director, Dr. Kurt DeBoos, wasted no time in getting a launch pad ready for the new rocket. But the proposed super rocket dwarfed anything heretofore handled by the Army Ballistic Missile Agency. The problem caused by the clustered engines were particularly significant. To guarantee proper ignition of all engines, the booster would have to be held on the launch pad for a few seconds. A complex mechanism to do this had to be developed. There was also the psychological factor related to Saturn's great expense. With previous military launches, launch equipment failures had been relatively inconsequential. Each program called for a number of tests. The Missile Firing Lab staff learned from mistakes. But the millions of dollars tied up in each Saturn meant that launch facility failures could not be tolerated. Finally, there was the problem of time. With the launch only 2 years away, there could be no serious delay in determination of criteria in design or in construction. While the launch facility was being readied, development work on the H-1 engine continued, and the first full-powered H-1 engine firing occurred in December 1958 at the Rocketdyne factory in Canoga Park, California. Concurrently with development of the H-1 engine, studies were conducted pertaining to the feasibility of a large single-chambered rocket engine. On January 9, 1959, Rocketdyne agreed by contract to design, develop, and test such an engine. The engine was designated as the F-1. This engine, burning liquid oxygen and RP-1 kerosene, would generate a very high thrust, approximately 1.5 million pounds. The next day, January 10th, construction of the ABMA static test stand for large boosters began. Meanwhile, Army representatives of the ARPA board visited the Atlantic Missile Range to discuss selection of a site for large vehicle launch facilities at Cape Canaveral, Florida. By February 1959, a contract had been awarded for construction of the blockhouse at the site, Launch Complex 34. A design contract was also awarded for a movable structure which would be used to assemble and service the vehicle on the launch pedestal. Now, at this point, the Army had a Saturn vehicle that needed a mission, and NASA had a mission for which it was seeking a vehicle. Perhaps a marriage of convenience could be arranged. Dr. Keith Glennon, first NASA administrator, had attempted to bring half of the von Braun team into NASA back in October of '58. But Secretary of the Army Wilbur Bruckner and General Medeiros successfully rebuffed that effort because the Army still had military projects to supervise, such as the Jupiter and Pershing, so they did not want to break up the von Braun team. Bruckner suggested as a compromise that NASA place a liaison group at Huntsville and plan to use the Redstone Arsenal facilities for certain programs. Since NASA really wanted the Saturn program, they reluctantly accepted Bruckner's proposal as the best of a bad deal. The deal was NASA would concentrate on smaller vehicles while the Defense Department developed larger ones, including the Saturn. Although this understanding appeared to secure a role for Saturn, it actually spelled trouble for the ABMA. The Huntsville organization had hoped that NASA would provide financial assistance for Saturn since the new space agency would likely use the big booster. But since NASA was unable to direct the Saturn program, they refused to underwrite any of its cost. But the project continued, and on February 3rd, an ARPA memorandum officially renamed the launch vehicle Project Saturn. ARPA representatives presented the proposed National Vehicle Program to the President and the National Aeronautics and Space Council on March 2, 1959. Included were the proposed Saturn B and Saturn C vehicle systems. On March 13th, the ABMA submitted to ARPA the results of the Saturn system study. This study indicated that either an Atlas or a Titan could be used as the second stage of the proposed Saturn vehicle. By May, ARPA had decided that modified Titan hardware would be used for the second stage and that the third stage could use a slightly modified Centaur vehicle. Also by May, the first production H-1 engine was delivered on schedule to the ABMA. ABMA's first test firing of this engine was performed successfully on May 26, 1959, and later the same engine would be used in the first test booster. Moving quickly ahead to July of 1959, construction of the Saturn blockhouse for Launch Complex 34 began at Cape Canaveral, and when the last Jupiter airframe was completed, Redstone Arsenal shops began retooling to support the Saturn project. Late in July, the Director of Defense Research and Engineering notified the Air Force and ARPA to consider common development of the Saturn second stage and the booster for the proposed Dinosaur project. Requirements for these stages appeared to be similar. Until review of this, neither agency was to make a firm commitment for the redesign of existing boosters or development of new ones. So, ARPA ordered the Army Ordnance Missile Command in-house and contractor work relating to the Titan second stage to stop, while studies of the proposed Saturn Dinosaur combination were in progress. However, work continued on the Saturn booster stage, and in September, two decisions reaffirmed the Saturn program. First, representatives of the Army Ordnance Missile Command, NASA, and the Air Force presented Saturn, Nova, and Titan C options to the Large Booster Review Committee of the Office of the Secretary of Defense. After examining the presentations, the committee recommended the clustered Saturn booster as the quickest and surest way to attain a large space booster capability in the million-pound thrust class. Then, Deputy Secretary for Research and Engineering Dr. Herbert York and Dr. Hugh Dryden, NASA's Deputy Administrator, reached a similar conclusion in their comparison of the Saturn and the Air Force's Titan C proposal. The York-Dryden Committee also recommended that ABMA conduct a study of second and third stages. As a side note, the Air Force's Titan C proposal employed a cluster of upgraded Titan I engines to provide a thrust comparable to the Saturn. In October of 1959, ARPA authorized the Army Ordnance Missile Command to proceed with engineering work for dock facilities for the Saturn booster, since it was too large and heavy to be transported by air or land. The dock facility would be located on the Tennessee River at the southern boundary of Redstone Arsenal. In December, Army Ordnance Missile Command was further authorized to construct the facilities and to build a barge to transport the booster to Cape Canaveral. Now I want to spend a little time on the Saturn upper stages. In November of 1959, NASA was given technical direction of the Saturn project, and of course, NASA immediately initiated another study. This one for the Saturn's upper stages. Dr. Abe Silverstein, NASA's Director of Spaceflight Development, headed a committee representing the Air Force, NASA, ARPA, and the ABMA. The Silverstein Committee established two criteria for a successful Saturn program. First, the development of a rocket with an early launch capability, and second, the rocket must be able to grow in capability. The group listed three missions for the initial Saturn vehicle. First, unmanned lunar and deep space missions with an escape payload of about 4,500 kilograms. Second, 2,250 kilogram payloads for a 24-hour equatorial orbit. And third, manned spacecraft missions in low orbits such as Dinosaur. The committee matched a number of configurations against these missions. Current ICBMs such as the Titan were judged unsatisfactory because they would not generate sufficient thrust for the lunar mission. A larger, conventionally fueled second stage, 5.5 meters in diameter, met mission requirements, but time and cost seemed excessive for a rocket stage with little growth potential. The solution lay with the early development of high-energy liquid hydrogen propellants for all stages above the first. In defense of this rather bold position, the committee noted, quote, "If these propellants are to be accepted for the difficult top stage applications, there seems to be no valid engineering reasons for not accepting the use of high-energy propellants for the less difficult application to the intermediate stages." The committee also recommended a building block concept, stating that vehicle reliability will be emphasized through a continued use of each development stage in later vehicle configurations, and they gave an example. The Saturn C1 would consist of the clustered first stage booster with 8 H1 engines, and the booster was designated S1. The second stage, designated S4, would consist of a new Douglas Corporation vehicle with 4 hydrogen-burning Centaur engines that could produce 15 to 20,000 pounds of thrust per engine. The third stage, designated S5, would be a modified Centaur. Now it gets a little complicated. The C1 could become a C2 by insertion of a new oxygen-hydrogen second stage with 2 150 to 200,000 pounds of thrust engines. The top 2 stages of the Saturn C1 would then become stages 3 and 4 on the C2 version. The committee proposed to launch 10 C1s starting in the fall of 1961. And on the last day of 1959, Administrator Glennon approved the Silverstein Committee's recommendations, and Saturn got its upper stages. Moving on to 1960. To develop the second stage of the Saturn C1, NASA sought a contractor. A bidders conference concerning this S4 stage was held at Huntsville, January 26, 1960, and by February 29th, 12 companies had submitted contract proposals. In the meantime, Redstone Arsenal scientists started to work on the first stage, and Saturn got another boost in January as well. The Eisenhower administration gave the Saturn project a DX rating, which meant it was a program of the highest national priority. Besides reflecting the administration's support, the rating gave program managers a privileged status in securing scarce materials. More important, the administration agreed to NASA's request for additional funds. The Saturn fiscal year 1961 budget was increased from $140 million to $230 million. Moving on to March. On the 15th, President Eisenhower officially announced the transfer of the Army Development Operations Division to NASA. He took the occasion to name the Huntsville installation the Marshall Space Flight Center for Eisenhower's old war commander, General George C. Marshall. The Department of Defense's Missile Firing Laboratory at Cape Canaveral became the Launch Operations Directorate of the new organization. Later in March, 2 of Saturn's 8 first-stage engines passed an initial static firing test of approximately 8 seconds. This test was identified as number SAT-01, the first live firing of the Saturn test booster. It occurred on March 28th. In the second test, SAT-02, on April 6th, 4 engines were successfully static fired for 7 seconds. All 8 engines of the test booster were successfully fired on April 29th in an 8-second test. Meanwhile, NASA reviewed the S4 proposals received in February, and on April 26th, NASA awarded Douglas Aircraft Company a contract to develop and build the second stage. In May of 1960, a second 8-engine static firing of 24 seconds duration generated a thrust of 1.3 million pounds. Also in May, NASA announced that Rocketdyne had been selected to develop the high-thrust J2 engine. This engine, defined by the Silverstein Committee in December 1959, would burn liquid hydrogen and liquid oxygen. It would be used in an advanced Saturn vehicle. On May 26th, assembly of the booster stage for the first Saturn flight vehicle began in Huntsville. During the second half of 1960, there were several successful static test firings of the Saturn C1 first stage, culminating in December with an all-8 engine firing for 60 seconds. Douglas Aircraft Company was selected to design, develop, and fabricate the Saturn second stage, also known as S4. Pratt & Whitney was selected to develop the LR-119 engine for the third stage, also known as S5. Convair was selected to build the third stage. And finally, construction began on the movable service structure for Launch Complex 34 at the Cape. This brings us to 1961.